Welcome to Kitchen Chemistry, a series where we do a few experiments in my home and you can copy them along in your home. Mostly in the kitchen, obviously, that's why it's called Kitchen Chemistry. This is aimed at people of all ages, and so there is a mixture of different difficulty levels and different understanding levels of chemistry. But never mind about that, let's do some chemistry. If you need to know about safety, which you do, read the instructions in the text below. Right, what do we need today? We need some copper wire. I seem to be fiddling with that first. This is a tiny bit of copper wire that was left over when I was making something in the house. You should be able to find some lying around. What I'm actually going to use for this experiment is this blue one here, which is a bit that I found in a skip. It's a piece of a main line, so it's got really thick bits of copper on it, and it makes it easier to show you. But any old piece of copper will do. Bigger is better. This is some vinegar. It's a German version of vinegar, so it's very strong, but I'm going to dilute it anyway. We need about 5% final solution, maybe a little higher. So I'm going to dilute this by a factor of 2 with water. We need a container. We need some salt. Normal table salt is fine. That's rock salt is better. Some water, a jug to measure it with, and something made of steel that we want to try afterwards. Zinc plated is fine. Now also we need a 9-volt battery, preferably one that's in the trash. So these are the ones out of my smoke alarm. What I did in that cut was mix 100 milliliters of water and 100 milliliters of vinegar, or use pure vinegar if you're using a relatively dilute one, so like a balsamico or something, or apple vinegar. I've added 2 teaspoonsful of salt. It's in the bottom now. I'm going to give it a stir with a piece of wire that I had lying around. It's all right at the moment to stir it. It's better to stir it with a stick or a chopstick or something so that you don't get your stainless steel cutlery in there, because it might cause damage. Obviously silver cutlery would be even worse, so don't do that. Wood and plastic is fine. The next thing to do is to attach 2 pieces of copper wire to the terminals of the 9-volt battery. I've stuck them on with some tape and got it so that it's quite stable. It's important not to short the 2 terminals of the battery. You can see that they're connected, just wrapped around them in this case, but you will probably have thinner cables. That cut was me moving it to a more open container. A jam jar like I had it in with a very small amount is kind of unsafe, because the hydrogen that you make can build up, and it doesn't build up in a fun way. It's a little bit dangerous. It could explode, but it probably won't. So it's much better to be in an open container like this. You should do this outside. I'm doing this with my extraction fan on so that the kitchen doesn't stink of vinegar the whole time, because it is quite stinky. And obviously the hydrogen that you make is going somewhere. So during this time, the electrodes are bubbling. It's quite difficult to get a nice sharp video of it, but the electrodes are bubbling. One of them is bubbling more than the other, and when I take it out you can see one of them is black and the other one is a funny colour. And while it was starting, a little pool of light blue colour built up around the positive electrode. You don't need to leave this for a really long time, because at some point the copper dissolving from one electrode goes and sticks to the other one, so you don't really gain anything anymore. As you can see, it's a very light blue colour, and I'm going to throw a zinc plated washer in there. I think it's a spring washer, and leave it for a bit. This isn't real time. It's been in there a little bit longer than that, and you can see a black coating builds up on it. That's the copper. It's depositing as the zinc is dissolving, and we'll be able to see that in a moment. It's not a great coating because the zinc is dissolving underneath it, and the zinc is not very sticky for copper. In commercial setups for putting copper onto things, they usually start with something else, either other copper or nickel typically. We don't have those, so we have to use something else at home, and so I've tried this zinc plated washer, and I'm going to try a piece of stainless steel, which we will see in a moment. But first, the results of this. What we want to see is this washer and a completely normal clean washer next to each other. So here we go. Take one out, put it on a plate, and let's have a look at it. You can see this is black already. Let's have a look at an original one. There it is, all shiny. I'll try and get a better picture of that. Well, let's go in closer. Here it is, kind of out of focus, but you get the picture. If I give this a rub with my fingers, you can see how fragile the coating is. It's just some copper, tiny copper particles on the surface of the zinc. So here I am about to give it a rub. You can see most of it comes off. It's not shiny underneath because some of the zinc has left, but it's not black either. It should be possible to coat some metals with copper, and this one on the left is a little stainless steel nut that I managed to coat with copper. That's its bolt next door to it, which didn't work as well. The nut has got a nice coppery colour to it, and the copper is well attached to the metal. I never worked out why this particular nut worked so well and the bolt that belonged to it didn't. I assume it's different grades of stainless steel, but I don't know. You can see that this process is comparatively simple to do in practice, but there are some complexities in what actually happens. Looking up on this whiteboard, we can see in the normal case, copper is covered with a copper oxide layer, and that makes it safe even if we leave it in water for quite a long time. If we put it into acetic acid or vinegar with some salt in it, it behaves very much like hydrochloric acid, and the copper oxide dissolves as copper chloride, but then it stops doing anything because there's nothing to oxidize it to take the electrons away from the copper. The process that we're using here is called complexing, and it's how negative ions surround a positive metal ion and help it to dissolve in water. So around that copper ion, the copper 2+ ion in solution, there would be some chloride ions and maybe an acetate from the vinegar. That would make it negative in total and make it very soluble in water, whereas the copper oxide in neutral water is not very soluble at all. If we go over to adding a battery, we're taking the electrons away from the copper and putting them into the battery. That helps it to dissolve, it helps it to be oxidized, because otherwise we have to wait for oxygen or another oxidizing reagent to come along, and they're not very quick in water, so we would have to wait a very long time indeed. But with a battery we can make it happen a lot faster, but we do have the problem that when the concentration of copper ions gets up too high, instead of making hydrogen at our negative electrode, which we would normally do, we start to use up the copper ions, and then we've just wasted energy. That's why I use an old 9-volt battery for this, because they're easy to get hold of and because they don't cost anything. On the deposition side, some interesting things are happening too. So if we throw in our zinc-plated washer, I think it was a washer, then zinc dissolves and copper deposits on it, but the copper crystal structure doesn't fit on the zinc at all. And so instead of growing a flat, nice layer on the top of it, it grows little tiny spikes and towers, whiskers on the top, which are easy to remove and appear to be black. If we have a better surface, like nickel, we can coat it entirely with copper, but nickel doesn't dissolve in the solution, so we also need to have some iron in there, and that's where the fineness of the stainless steel comes in. If the stainless steel is too good, none of the iron will dissolve and it won't work, or if it's been heat treated. If the stainless steel is too bad, then there's too much iron in it and it won't work either. Just right means we end up with a copper layer on the top. Unfortunately, I can't tell you what that is because it was a piece of stainless steel that I found in my house. Using the battery to try to deposit some copper onto a normal piece of stainless steel doesn't work very much better either, and that would probably be because instead of having a nickel surface, it's got a chromium surface, and that doesn't act as a good layer for copper to stick to either. Finally, be careful disposing of this solution. It's not very much, so you can probably pour it away, but be careful with it. It shouldn't come anywhere near food. All of the containers should be washed afterwards before being used again.